Recall that Locke has this pretty simple intuitive theory about how it is that we think and that we get ideas. We go out into the world, we look at things like a penguin on the left here, and the bits of that penguin somehow hit our various sense organs, our retinas on our eyes, or the haptic nerves on our hands, and they give us an idea of a penguin over on the right here in our minds. And so what Locke is doing in this reading I gave you this week is just elaborating on what goes on exactly when we transfer an actual object in the world, this penguin, and translate that into an idea in our mind. And what Locke says is that there are really two kinds of properties that things in the world have, and that they interact with our minds in different ways. So first, we've got these primary properties. These are properties of shape and size and motion. These are things that most of the things we encounter in the world actually have, and the reason that we see this apple as being a certain size and shape is because, well, it is actually that size and shape. Those are primary properties that it has, and we're able to take those properties and copy them directly into our minds. But then there are these really unique properties that Locke calls secondary properties. So these would be things like the property of being cold, or being red, or being a shadow even. And these are things that, unlike motion or shape or size, these don't seem to be things that anything in the world actually has, according to Locke. Instead, he says, look, if you touch something that's cold, there aren't any particles of cold in that object. There's no coldness in that object. No, that cold, that's just an idea that you have because of the way that the particles that make up that object affect your senses. In this case, we know that it's when you have an object with really low kinetic energy. When you touch that object, the particles of that object start to take energy away from your own tissues, which stimulates your nerves in a certain way, which then gives you the idea of coldness. Same thing when it comes to color. When you look at an apple and you say, aha, that apple is red, well, there's no real redness in that apple, Locke points out. There's no particles of red. Instead, what's happening is that there's some photons of light that are bouncing off that apple and hitting your retina. And it's because those photons of light have a certain wavelength of, say, 450 nanometers that they cause then the cells in your retina to isomerize at a particular rate, which cause certain nerves to fire going back to your occipital lobe, and eventually, somehow, you get the idea that the apple is red. But there's no redness in the apple the way that there is actually a shape and a size to the apple. So color, coldness, these are these secondary properties, these properties that objects have to create certain ideas in us, even though there's nothing in particular in the object itself that corresponds to those ideas. So if you're not sold on this, let me just give you a couple examples. So go back to the start of the term and check out the dress. Now, what's going on here is that there are indeed photons bouncing off the screen of your computer right now into your retina, coming off the parts of this image. And it just so happens that in some of you, those photons, which are all the same wavelength for all of us, their motion and speed and size, those are all primary properties of those photons. So they're all the same for all of us. But it turns out that the way that color works, our minds process color differently depending on, well, things like what kind of cone cells we have in our eyes, but also according to what other things we happen to be looking at a particular time, and what other kinds of light are hitting our retinas at any given time. So in general, the explanation of why some people see this dress as white and gold and other people see it as blue and black is that the way that our mind is processing those incoming photons is different, just depending on, well, what we've been looking at earlier or after looking at this dress. So I'll give you some more concrete examples. So if you look at this image, most people usually see the circle on the left as being a different color than the circle on the right. However, the photons of light, the wavelengths of light bouncing off those two circles are exactly the same. You can check this out right now if you take a piece of paper and cover up the colors that are surrounding each circle and just look at the middle of the circle. And if in that case, you'll see that, those circles look to be exactly the same colors. But because of the way that your mind processes colors, the surrounding color influences how you interpret the color of different objects. So even though it's the same wavelength of light, you've got the same primary properties coming off of the first circle and the second circle. The secondary properties, the idea of what color that you get, is different for the circle on the left and the circle on the right. Same thing here. A lot of folks, when they look at this image, they will see a kind of light green figure on a white background, even though the color of the figure in the middle is the exact same color as the paper around the outside. I say color, but really I should say the light wavelengths, the primary qualities are all the same, but your mind generates different secondary properties because of the little green squiggles that kind of cause you to perceive that the part of the surface inside the green squiggles as being kind of light green itself. Here's some more fun ones. If you were to measure, you would find out that this middle square up here is emitting exactly the same wavelengths of light as this square down here. Even though to most people this looks orange and this looks brown, this looks bright, this looks more dull. No, they're emitting the same wavelength of light. It's because your mind processes color in terms of the other colors that it sees around it, that it processes the secondary property of this as being different from the secondary property of that, even though they both have the same primary properties. Here's another example. So all the squares over on the left here that look red to you are actually orange, and all the squares over here that look red to you are actually purple. That is to say, while there's no like red property or purple property that's a primary color of those squares, but if you were to take away the surrounding colors, you would perceive what you perceive to be red here to be purple, and you would perceive what you perceive to be red here to be orange. Here we've got a nice example where all the squares that you probably perceive to be blue over on the left-hand image, and all of the squares that you probably perceive to be yellow over on the right-hand image here, they are all giving off exactly the same wavelength, namely the one that you can see down on the bottom here, a wavelength that you would perceive to be gray if it were not surrounded by these other colors. Here's one more example. Most folks take a look at this image and they see that these strawberries are red, but if you sample the little bits of color from places where these strawberries are, and you just line them up over here without all the context that you get over here, you'll see most people see these little swatches as being bluish or grayish, even though these swatches are just swatches of color that we've taken from where these red-looking strawberries are. So again, here's a case where we've got the same wavelength of light. When it's over here against a white background, it looks kind of bluish, greenish, gray. But when it's over here in a different context, you get another secondary property. It looks reddish to most people. So Locke says, look, it's not just color. There's other things like coldness or flavor. A lot of you, unfortunately, might have noticed that if you get COVID, it can interfere with your ability to smell and taste things. And unfortunately, even when folks are getting back their smell and taste, sometimes it has changed because their nerve cells have been damaged by the COVID virus. And so the way that little particles of molecules of ice cream or of other things that you taste and smell, the way that those things affect your taste buds, your smell receptors, those are different effects now, and so you get a different idea. So the primary properties are all the same, but the secondary properties have changed because the secondary properties depend on how you process the taste and the smells. Here's another example having to do with color. If you're like me, you see the image on the left as being full of lots of different colors: red, green, orange, yellow. But if you're somebody who's red-green colorblind, you're going to see that image on the left more like the image over on the right here. And Locke points out, look, that's not because you're failing to pick up the red particles or the green particles that are in the fruits. It's just that me and somebody with red-green color blindness, we just have a different apparatus in our minds that causes us to interpret the primary colors of the wavelengths bouncing off those fruits and vegetables differently. There is no color in those fruits and vegetables. Color is just a way that we interpret the primary properties that those fruits and vegetables have, namely their shape and their size and their speed and their motion. One more example that Locke talks about, he points out that temperature is a secondary property as well. So if you're like this little kid here and you take, say, the hand of hers that's on the right and put it in a tub of really hot water, and the hand of hers that's on the left and put it in a tub of really cold water, and then you've got a tub of just kind of like lukewarm room temperature water in the middle, well, the hand of hers that's on the right that was in the warm water, when she puts it in the middle water, it's going to feel really cold to her. And of course, the hand of hers that's on the left that's been in the really cold water, when she puts it in the tub in the middle, that tub in the middle, that water is going to feel quite warm. So she's going to be feeling the exact same water that, of course, has the same primary properties. It's got all these little water molecules that are moving at the same speed and are at the same size. But the hand of hers that's on the right is going to interpret those same motions as having a cold property to them, whereas her hand that's been soaking in the ice water is going to interpret those very same primary properties as giving a warm sensation. So again, the warmth or coldness of the water, Locke argues, is not a primary property of the water itself. It's just part of the way that the actual primary qualities, the shape, size, and motion of the water molecules affects our senses. And so these ideas of heat and cold, color, smell, taste, these are just ideas that we interpret the world in light of, but don't reflect anything that's actually in the world itself. Now, what we're going to see in our next reading is that Berkeley takes the same idea from Locke, and he argues actually all properties are like this, and that's he's going to use to show that actually everything that exists is an idea. Everything is a secondary property, an idea of some kind. There is no distinction between real physical properties, primary properties of objects like motion, speed, size, solidity, etc. on the one hand versus things like color, taste, and smell on the other. No, Berkeley's going to argue Locke didn't go far enough. Actually, everything is an idea. So I'll come back with a video for you on that.